everyone, welcome back. In this video I will show you how to run the Breusch-Pagan test for heteroscedasticity in SPSS. The step is a bit long, so I want you to watch closely and also take notes. Before I dive in, I want to quickly take you through the hypothesis as well as the decision rule. Take note that this particular test is used for heteroscedasticity. Breusch-Pagan test is a statistical test used to detect heteroscedasticity, which means unequal variance in the error times of a regression model. Don't forget that in the previous video I told you that homoscedasticity is a situation whereby the independent variables have constant variance. So when the independent variables or the error times, when the variance of the independent variables or error times are not constant, then we say there is a problem of heteroscedasticity. But in a situation whereby the variance are constant, then the model is homoscedastic and it is suitable for analysis using parametric approach. So this is the hypothesis statements for Breusch-Pagan test, the non-hypothesis and the alternate hypothesis. The non-hypothesis is simply homoscedastic, that is equal variances. In this case, the variances of the independent variables are equal. The alternate hypothesis is heteroscedastic. That simply means unequal variances. So when the variances of the independent variables are not equal, we say there is a problem of heteroscedasticity. But the situation where the variances are equal, then that means the model is homoscedastic. This particular assumption is also very important, as I've said in the previous video. So if your model violates this particular assumption, then it means that your regression results will be biased and it may be misleading. Now let us look at the decision rule. This particular test, the analysis is not straightforward like others, because in this case you have to compute the Breusch-Pagan test statistics. Also, you need to have your critical value tables, and if you don't have that, you must also know the different method of computing the critical value as well as the probability value. So if the test statistics, that is the Breusch-Pagan test statistics, is greater than the critical value, then what you need to do is to reject the non-hypothesis, and that means that heteroscedasticity is present in your model. In other words, the model suffers from the problem of heteroscedasticity. But a situation whereby the test statistics is less than the critical value, you need not to reject the hypothesis. That is, you fail to reject the non-hypothesis. And it's simply when you fail to reject the non-hypothesis, what it means is that there is no evidence of heteroscedasticity. That means there is no problem with your model. Another thing you may look at is the probability value. So if the probability value is less than 5%, you need to reject the no. In that case, there is a problem of heteroscedasticity. But if the probability value is greater than or equal to 5%, that is 0.05, you fail to reject the known hypothesis and you conclude that the model is homoscedastic. The model is good. Parametric approach or techniques of analysis are suitable to analyze such model. So let's go to SPSS so that I can demonstrate or show you how to run the Breusch-Pagan test. Here is my SPSS work file. This is the work file, and please take notes in this particular video. You must know how to use Excel. You must know how to check critical value in chi-square table. Also, if you know how to use the R or R square, there won't be any issue. So to do Breusch-Pagan test in SPSS, the first thing is to run a regression analysis. You need to run a regression analysis. After that, you now proceed with the test. So let us do that. Let us conduct the regression analysis. To do that, you go to analyze, then you move to regression. After regression, you go to linear. Next thing is to determine your dependent variable and independent variables. So here we are going to use the independent variable that I used in the previous video. The dependent variable is weight, so you move weight to this place. Next is current salary, you move it to independent variable. Other independent variables are age, then employment category, you move it here. The next thing you need to do is to go to save. Here you have to tick on standardize. You need to tick on standardize, because when you tick this, SPSS will automatically generates the residual for you. But if you did not tick it, there is no way you can see that in your work file. So once you tick this, then you click continue. After continuing, you click OK. Now we have our results. And another thing is that SPSS has automatically generated the residual for us, the unstandardized residuals. So now we have our results here and we have our unstandardized residual. But we have nothing to do with this particular result now, because our focus is to estimate the Breusch-Pagan test statistics. So the next thing that we need to do is to create the square of this particular variable. So to do that, we go to transform. Once you click on transform, then you click on compute variable. Once you click on compute variable, you have this particular something like this. Which variable do you want to create? In this case, we want to create the square of this particular residual. So the target variable now is the square of this residual. So you say resid underscore square. For that square, you can just say SQ. And if you like, you can write it in full, but it is better you shorten it. Then the numeric expression will now be square of this particular variable, the residual, square of this residual. So you type res underscore 1. You now multiply it by 2. So to do that, you press shift on your keyboard, then the star button, asterisk, you press it twice. Then you have that. Also, if you don't want to use the keyboard, you can use this particular one. You click on this twice, 1, 2, then you type 2. You can also use this screen keyboard, you type 2. So this is the expression of this particular variable. What we want to do here is to generate the square of our residual. So now once you have typed this here, the next thing is to click OK. Immediately, okay, the sequence is invalid. Okay, something is strong here. There is a space. Yes, there shouldn't be space. So I think we have like 3 spaces. So you make sure there is no space here. Everything should be together. Then you click OK. Still send the same thing. The sequence of operator find the same. Check the expression for omitted or extra operand, operator or parenthesis. What is happening? Let me use the keyboard start. Then 2. Okay, you can see, I think there's an error with that. Now you cannot see the residual. This is the square of this particular residual. This is the square. The next thing now is to estimate, to rerun the regression using this square as the dependent variable. So you go to analysis, regression, then from regression you move to linear. Here now you remove this, the dependent variable, the existing dependent variable, take it out, then the new variable generated, the residual square, you move it here. So once you move the residual square there, the next thing is just to click OK. Now we'll have our outputs. Here is our outputs. The only thing we want to take here is the residual. The only thing we need here is the residual of this particular coefficient. Oh, sorry, the R square. The only thing we need is the R square. This is the R square. You can see it in model summary. This is the R square. So we need this particular value. So let's write this value out. Let's write it out. What is the R square? The R square is 0.016. Now we'll use these R squares to generate the Breusch-Pagan test statistics. And how do we do that? You need to know the sample size. So the Breusch-Pagan test statistics, let me quickly copy it so that I won't need to be typing long. We want to obtain or to calculate the Breusch-Pagan test statistics now. So now to do that, you type this. Breusch-Pagan test statistics is equals to our sample size multiplied by the R square. Sample size multiplied by the R square. So now we know the R square, which is 0.016. To determine our sample size, we go back to our work file. Okay, we don't even need to go back. You can see that here it should be in this particular summary. Okay, this is our sample size and the sample size is 200. So now we have the sample size. So this will be equals to 200 multiplied by 0.016. So you get your calculator. This is my calculator. Then you multiply it. 200 multiplied by 0.016. Whatever it gives us is our Breusch-Pagan test statistics. So what it gives gives us is 3.2. So our test statistics, the Breusch-Pagan test statistics is 3.2. Now the next thing we need to do is to obtain the chi-square critical value. The chi-square critical value, don't forget, you also need to know, to get your chi-square, to get the accurate chi-square statistics, you need to know first the significance level you are looking at. The significance level we are looking at is 5% is 0.05. Don't forget that's because we estimated this result at 95% interval. So the significance level we want to use here is 0.05. The next thing we need to know now is the degree of freedom, and our degree of freedom is equals to the numbers of the independent variables. How many independent variables do we have here? Let's check. We have employment category, we have age, we have current salary. So that simply means that we have three independent variables. So now we can go to chi-square critical value and check for the chi-square critical value. Since we know the degree of freedom and we know the significance value, I have that here already. So this is the chi-square critical value. You can see this is the 5% we are looking at, and the degree of freedom is 3. So here we can just trace it. Look at the way the points at which this one and this one intersect, and the value is 7.815. The value is 7.815. So the chi-square critical value is 7.815. I want to confirm that 7.815, correct. Now let us go back to the decision rule. What does it say? This is the decision rule if you want to use the test statistics. It says that if the Breusch-Pagan test statistics, this one, is greater than the chi-square critical value, rejects the known hypothesis. Now let us check. You can now compare the two. Which one is greater? You can see that the chi-square critical value is greater than the Breusch-Pagan test statistics. The Breusch-Pagan test statistics is 3.2, while the chi-square is 7.815. So in this case, we have to reject the known hypothesis and conclude that there is a problem of heteroscedasticity. That is, the variance are not constant. The variance of the error times are not constant. The second one says if test statistics is less than critical value, chi-square critical value, you fail to reject the known hypothesis. In such situation, no evidence of heteroscedasticity. So now, since we cannot conclude that, since this is the conclusion based on this particular result, since the Breusch-PP test statistics, and what is the test statistics? 3.2 is less than the chi-square critical value. What is the chi-square critical value? 7.815. We fail to reject the non-hypothesis and conclude that the model is homoscedastic. That is the variance of the error times are constant. That is the conclusion. So based on this particular result, we can say that the variance of the error times are constant, and hence there is no problem with this particular model. Another thing we can do is to estimate the probability value. And to estimate the probability value, you can make use of Excel, you can make use of chi-square calculator, and you can also make use of app. But in this particular tutorial, I'm going to use Excel as well as app. Now, to use Excel, you need to take note of first the Breusch-Pagan test statistics as well as the degree of freedom. You need to take note of those two. And from here, we know the degree of freedom, which is 3, and we know the Breusch-Pagan test statistics, which is 3.2. So now we can go to Excel and calculate the probability value. To do that, first you type equals to, then the formula is this chi-square. So you are going to pick this particular one, RC. What is the Breusch-Pagan test statistics? 3.2. And what is the degree of freedom? The degree of freedom is 3. So brackets close, then enter. The probability value is what? 0.36, which is greater than 5%. Take note, if the p-value is greater than or equals to this, fail to reject the known hypothesis. So the results, our conclusion here is valid because the p-value is what? Is greater than 5%. Our p-value is 0.36. P-value equals to 0.36, which is greater than 5%. Another thing we can do also is to make use of R square. I have the formula here. For R square, you can just use this particular formula. Once you open your R square, you press this, P of chi-square. This is the Breusch-Pagan Test statistics. This is the Breusch-Pagan Test statistics, and this 3 is the degree of freedom. This lower tail will be equals to 4. So once you click on run, you have your results here, which is 0.36, which of course is the same thing with what we have obtained in Excel. So now I believe that you can now run Breusch-Pagan test for heteroscedasticity in SPSS. Also, I know now that you can estimate the test statistics for Breusch-Pagan. You can also determine the critical value using the chi-square table. Also, you can calculate the probability value using Excel as well as R square. Please don't forget to subscribe to our channel for more tutorial video on research, data analysis, and others. Share our video with your friends and your colleagues. I also will appreciate if you can thumb up, you can like our video, and don't forget, if you have any other question, you can just tap it in the comment section. Once we see it, we will respond to it. Thank you.